You know, every single millisecond counts. That slow loading bar on your app, it's not just a tiny delay. Think of it as a leaky bucket for your user base. So today, we're going to patch that leak by diving deep into optimizing your Android app's startup.
A slow start doesn't just annoy people, it can make them give up and abandon your app for good. It's kind of like the silent killer of engagement. So let's grab our magnifying glasses and play detective, because we are going to solve the case of the sluggish start.
All right, here's our game plan. We'll start by understanding the crime scene. Then we'll gather some evidence with our profiler toolkit. After that, we'll identify the usual suspects and finally bring them to justice with some fixes at both the code and build level.
Okay, first things first, we need to understand the crime itself. Why is a slow startup so bad for your app? What's actually happening behind the scenes? And what clues should we be looking for?
So our investigation is going to focus on what's called the cold start. This is when your app launches from a complete dead start. Nothing's in memory, it's starting from scratch. Now, it's definitely the toughest case to solve, but the good news is, when you optimize for a cold start, you automatically improve the performance of warm and hot starts too.
So this slide here, this reveals our two most important clues, TTID and TTFD. Time to initial display, or TTID, that's the very first moment the user sees anything at all, maybe a splash screen or a loading spinner. But the real story, the one we care about, is told by TTFD, time to fully drawn. That's the moment the app is actually interactive and, usable. One measures perception, the other measures function.
So how slow is too slow? Well, Android Vitals, a key witness in our case, says your app's startup is excessive if a cold start takes 5 seconds or longer. For warm starts, that number drops to just 2 seconds. Honestly, a 5-second delay is an eternity on a phone, and it's pretty much a guaranteed way to lose users.
To crack this case, we can't just guess what's wrong. We need the right tools to gather hard evidence and pinpoint exactly where the slowdowns are happening in our code.
You know, any good detective follows a process, right? This 4-step mindset is what keeps our investigation on track. First, clearly define the problem. Then, reproduce it reliably. After that, validate your theories with the profiling tools, and only then do you go in and apply the fix.
Every detective needs their toolkit, and this is ours, and it is packed. Think of these profilers as our forensic instruments. We've got tools to check for graphical glitches, like dropped frames, and others that let us do a full autopsy on our code to see exactly what the CPU was up to millisecond by millisecond during startup.
The GPU profiler is often our first clue. See, each of those bars represents a single frame being drawn. For a super smooth, 60 frames per second experience, each frame has to draw in under 16 milliseconds. That's that green line. Any bar that shoots past it is a dropped frame, which is what the user sees as a stutter or lag. We usually just call it jank.
And this is brilliant. This shows us where the time is actually being spent. A system trace, especially with this flame chart view, lets us zoom right in on specific functions and see exactly how long they're taking to run. The really wide parts of the flame, those are our biggest time sinks, our prime suspects.
So, with all our evidence gathered from the profilers, a few common culprits, our usual suspects, almost always emerge from the investigation. Let's take a look at the lineup.
After looking at all the evidence, the slowdowns nearly always trace back to one of these 5 things. We're either doing way too much heavy lifting right at the start in methods like onCreate, or we're trying to render a massive, complex UI. Or we're blocking the critical main thread with slow disk or network calls, and in the world of Jetpack Compose, a big one is trying to draw the entire UI all at once.
Okay, let's move on and see how we can apply some tactical fixes to deal with these common suspects right in our code and hopefully get some immediate performance wins.
A fantastic strategy, actually borrowed from web development, is the above-the-fold technique. The idea is super simple. Only draw what the user can see right away. Everything else, all the stuff off-screen, it can wait. And, one analysis of a slow Compose UI found this exact problem. It wasn't that individual parts of the UI were slow on their own. The issue was that the app was trying to compose and render everything all at the same time, which created this huge bottleneck on the main thread.
So the fix is to delay the composition of anything that's not immediately visible. By spreading that workload out over time instead of demanding it all at once, you free up the main thread and the UI becomes responsive much, much faster.
And this same principle doesn't just apply to UI. It applies to creating objects too.
Don't initialize heavy things like network clients or databases right at startup if you don't absolutely have to. Using lazy initialization, for instance with Dagger's provider, makes sure an object is only created the very first time it's actually needed.
All right, now for the ultimate weapon in our arsenal. We've made some good code-level fixes, but for a really massive, lasting performance boost, we need to look at optimizations that happen at the build level.
Think of baseline profiles like giving the Android system a pre-translated script for your app's most important user journeys, like startup. So instead of interpreting code on the fly, which is slow, the system uses this profile to compile it ahead of time. That means it's ready to run at full speed from the get-go.
And the impact is huge. Seriously, shipping a baseline profile can improve code execution speed by about 30%, starting from the very first time a user opens your app. That is a massive win, and you barely have to change any of your main app code.
And for an extra boost, startup profiles take this a step further. They don't just tell the system what to pre-compile. They physically reorder your app's code inside its compiled files to make sure the most critical startup stuff is all packed together. This minimizes the time it takes to find and load it from the disk.
And that's the case file closed. We went from finding the first clues like TTID and TTFD to gathering forensic evidence with profilers, applying tactical code fixes, and finally, deploying our ultimate weapon, build-level optimizations like baseline profiles.
So, you've now got the case file and the complete detective's toolkit. The only question left is what performance bottlenecks are hiding in your app. It's your turn to be the detective. Happy hunting!